Hallo, it's Dumplet here. Here's an item on geometry. Take a look at the figure on the left. An octagon is inscribed in a square of side length 4 plus square root of 8. 4 red semicircles are inscribed at the corners, as you can see. Find the total area of the 4 semicircles. And this item came from DAM 2022, an examination that Dumplet has hosted. The link to the PDF file will be in the description. Alright, so we have a regular octagon inscribed in a square, so we can make use of the nice symmetry that we have here. So let us try to draw some lines to form this kind of a figure on the top left corner. So I'm going to draw this one and this one, right? And essentially I'm completing a square. So I'll have a small square here because of nice symmetry, because we have a square in the figure. And well, I'm going to duplicate, I'm going to kind of reflect the semicircle, and here I'll have a full circle here. Now it's going to be reflected across this line over here, right? A side of the octagon in this case. Alright, so from what we see here, the side of the square is twice the radius of the circle, right? That's why I have here 2r. So it's reflected in here and here, right? Now let's just say we have S to be the side of the octagon. And well, because we have a nice right triangle here, we can try to solve for S with the Pythagorean Theorem. So 2r squared plus 2r squared, that should be equal to S squared, right? Now the square of 2r, that's 4r squared. So that's going to be 8r squared equals S squared. And then we take the square root. S is equal to, again, technically plus minus, but just take the positive root over here because we want the lengths here. So 8r squared, the square root of that, it's going to be 2r times the square root of 2. So S over here would be 2r times the square root of 2. Now this is very helpful because it is the side of the regular octagon in the figure. So now we can try to see here, we have nice symmetry and all. So this part would be the side of the square, the smaller square that we formed here. All right, that's going to have 2r. And same thing down here, that's going to be 2r. And this part, it is the side of the octagon, so it's going to be 2r square root of 2. Now if I add the 2r, the 2r square root of 2, and the 2r, I should be able to get 4 plus square root of 8 because that's given to be the side length of the square. So what I'm going to do here is the following. Alright, so I know that 2r plus 2r, that's going to be 4r, and then I'm going to add this 2r square root of 2, so plus 2r square root of 2, and that would be equal to 4 plus square root 8. Now square root of 8, that's 2 square root of 2. And we can just do some comparing here. I have 4r and 2r comparing with this 4 and the 2. I could easily get from here that r must be 1, right? Because if r is 1, this becomes 4 and this becomes 2 square root of 2, and it would be the solution. So apparently the radius of the 4 circles, the 4 semicircles we have here, they all have a radius of 1. So 4 semicircles with radius of 1, that's also that's going to have the same area as 2 circles with radius 1. So recall the formula for the area of the circle is simply pi r squared. You have the area, so you have the radius to be 1. So one circle will have an area of pi times 1, which is just pi. But we have 2 circles here, so 2 times pi, simply going to give us the final answer of 2 pi. And this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!